Hello friends, I am K. Vidya, Head of the Department of Civil Engineering, Mahindra Engineering College, Namakkal. Today we discuss about the topic of the concrete technology. Infrastructure development is going in an exponential manner. So the infrastructure development is a building development. So the building, most of the building structures made up of the concrete is the predominant one. In our world, water is a major component occupied in this space. The next one is the concrete. So concrete is made with the following ingredients, that is the cement, fine aggregate, coarse aggregate and water. Finally we are adding for the admixtures. The admixture is classified mineral and chemical admixtures. So the cement is classified on the types and grades. The type of the cement is ordinary Portland cement and PPC Portland cement, quick setting cement, warning cement, colored cement. The next grade of the cement, 33 grade of the cement and 43 grade of the cement and 53 grade of the cement. The number is indicated as the grade of the cement and the compressive strength of the cement. The main test for the cement is consistency test, initial setting time and final setting time, soundness of the cement and compressive strength of the cement. So consistency, by using the Vicat apparatus, we determine the consistency value of the cement. Then find out the consistency value, we are going to find the initial setting time of the cement. The initial setting time as per the code IS 456-2000, the minimum value of the initial setting time is 30 minutes. By using the Vicat apparatus, needle can be used to find the initial setting time of the cement. After getting the initial setting time, we are moving for the final setting time of the cement. The final setting time of the cement, we are replacing the needle with needle angular attachments. This needle angular attachment is fixed in the Vicat apparatus. We are using this setup by using the consistency test. We find the final setting time of the cement is maximum 10 hours. The next important test for the cement is the soundness cement. The soundness cement is the main property for using the cement. The soundness cement, we determine the expansion of the cement. As per the code, allowed maximum expansion of the cement is 10 mm. By using the Lichat apparatus, we used for the soundness or expansion of the cement. As per the code recommended, 10 mm is the maximum expansion. The next moving for the cement testing is the compressive strength. The compressive strength is very important, predominant for the cement, because this compressive strength can be implicit for the types of the cement and the grades of the cement. This grade of the cement is determined by using the compressive strength of the cement. This compressive strength, we are taking the cement 1 part and 3 part of the sand. We are mixed together, then adding the water depends on the consistency value we got from the cement. So this water percentage we are adding, then cement with 3% of cement. We are taking the mold 70.5 by 70.5 by 70.5 mm. We are filling the concrete cement mortar in this mold. Then next day we are demolding the mortar cube, then immersed in the water. After 20 days we are taking from this mold specimen from the water. We are having the compressive strength apparatus. By using this compressive strength apparatus, that is the compressive strength apparatus capacity is 110 or 210. We are applying the universal load for the vertical direction. We note down the first crack load and then maximum failure load or ultimate load of this specimen. The load divided by cross section area of the cube gives the compressive strength of the cement. This compressive strength value is indicated as a Newton per mm square or megapascal. So this value is indicated as a grade of the cement. The 33 is Newton per mm square or 33 megapascal gives the compressive strength value of the cement. The next moving for the fine aggregate. Now we are using for sand is the fine aggregate. Technical name is a fine aggregate. So main important property for the fine aggregate is water absorption, specific gravity and moisture content is used for the making the concrete. So fine aggregate is the sand. The particle size is 4.75 mm, lesser than is the fine aggregate. We determine the specific gravity by using the micrometer. Then by using the O1 we determine the moisture content and then water absorption capacity. The next moving for the coarse aggregate. Coarse aggregate we are generally used for the metals or gravel. That gravel or metal technical name is a coarse aggregate. In coarse aggregate is occupies the 70% volume of the concrete. So the main test for the coarse aggregate is the same specific gravity and water absorption and weight density and compressive strength and crushing value and impact strength. The crushing value and impact strength based on this value we can use for the concrete structures or pavement structures. The value is less than 35 the concrete structures. Then moving for the next one is the water. Water is the main role for the concrete because the water quality is very very important to making the concrete. So water percentage is inversely proportional to the compressive strength of the concrete. So the water content is higher means we are getting the slow down the value of the compressive strength. We are using for the less water cement ratio, we are getting higher compressive strength of the concrete. Then important property for the water is the pH value and then hardness and total solids. In pH value it can be limited as lesser than 7 and then hardness is given in as per the code, then total solids also given as per the code 456/2000. Then another one important, nowadays we are using for the trend in the admixture. The admixture is classified two. One is the chemical admixture, another one is the mineral admixture. In chemical admixture we are using to reducing the water content and by using the accelerate the compressive strength and then slow down the process. These are all the chemical admixture. The name is plasticizer, super plasticizers, retarders and then accelerometers. These are all the used for the chemical admixture. Then another one is the mineral admixture. These mineral admixture can used to replace the materials for the cement. For example, fly ash is one of the replacing material. Then rice gas, bagasse ash, pond ash and then GGPs are also used to replace the cementitious material. These materials possess the cementitious process. So these are all the mineral admixtures used to making the concrete. So this is the main ingredients for making the plain cement concrete. Now we are moving for the concrete testing. The concrete testing is divided into two categories. One is the fresh concrete status, another one is the hardened concrete status. In fresh concrete status means we determine the workability, that means the flowability of the concrete. The flowability can measure slump cone apparatus, then BB consistometer, then compaction factor and flow table. So these four tests is used to measure the flowability or working ability of the concrete for the fresh state. So the slump cone and BB compaction factor and the flowability is used to various types of workability. For example, low workability and medium workability, high workability and then very high workability. For example, we are taking for the slump cone apparatus, the size of the slump cone is in height is 30 cm and then bottom diameter is 20 cm and top diameter is 10 cm. We are making the concrete for the proper mixed proportion, for it should be depends on the grade of the concrete. The grade of the concrete means it can be very M5, M10, M15, M20 up to M200 nowadays we are using. Up to M55 this is the normal strength of the concrete. 60 and above is the high strength of concrete. So these concrete first we initially test for the fresh concrete state, that is the workability of the concrete. We already told the water cement ratio is the main predominant role in the compressive strength of the concrete. Here we determine the water cement ratio and the workability of the concrete. In case we are reducing the water, we are getting the more compressive strength of the concrete. For taking the slump cone test, we arrive the mixed proportion. For example, M20 means 1:1.5:3. That one proportion is a cement and 1.5 proportion is a fine aggregate and then 3 proportion is a coarse aggregate. Then 0.45 is a water cement ratio for the M20 grade of the concrete. We are preparing this concrete mix. We ready for the slump cone. The slump cone apparatus setup is cone is height is 30 and then bottom diameter is 20 cm, top diameter is 10 cm. We are filling the concrete in the slump cone in 3 layers. So first layer we filled, then 25 times tapering by using the tapering rod. Then second layer filled by using the tapering rod. We blow the 25 times and then third layer filled and then top is tapped by using the tapering rod in 25 rows. Then we remove the slump cone. We measure the slump cone value. So initially the cone height is 30 cm. After removing the cone, what is the difference between the cone height and the original height of the slump? Based on this, we have to classify true slump or collapse slump. So based on that value, we have to use for the concrete classification. So this is the slump cone apparatus. This can be used for the low slump value. Then next moving for the BB consistometer. The same concrete mixed proportion we are taking. The same concrete mixed proportion filled with the BB apparatus. This BB apparatus is cylindrical cylinder with slump cone. We can fill the concrete in the slump cone. We remove the slump cone. We start the motor. The cone is coming for the horizontal direction. That time taken to measure for the BB consistometer. So this BB consistometer is used to determine the workability of the very low workability factor. Then another one is here compaction factor. The compaction factor The compaction factor is used to measure the medium workability of the concrete. So this is, we are having the hopper, two hopper, then one cylinder base. We are filling the same mixed proportion in the first hopper, then open the first hopper, the concrete is filled in the second hopper, then we open the second hopper, the concrete is filled in the cylinder. So the weight of the cylinder plus concrete will be taken down, that is a partially filled concrete. Then this concrete is poured in our tray, then we fill the concrete in the cylinder in 3 layers, the same what we explained in the slum code. So first layer we filled, then 25 times tapering, second layer filled 25 times tapering, third layer filled 25 times tapering. The ratio between the partial filled concrete to total filled concrete is gives the compaction factor value. So these three is the very important property of the fresh concrete property. Then next moving for the hardened concrete property, that is the compressive strength, tensile strength and Young's modulus of the concrete. The compressive strength value gives the grade of the concrete. The grade we already explained, M5, M10, M20, M50. That M is indicated as a mixed proportion or mixed design. That number 5 or 10 or 20 or 25 is indicated as the compressive strength of the concrete. So the 5 means 5 Newton per mm square. So we prepare the cube mold specimen of size 150 mm by 150 mm by 150 mm. Then after 28 days we testing by using the universal testing machine. We apply the vertical load or axial load. Then we note it down the failure load that gives the compressive strength of the concrete. So the compressive strength is the important property of the hardened concrete. Then tensile strength of the concrete, we measure by using the cylinder specimen, we measure the tensile strength 2P divided by pi dl gives the tensile strength of the concrete. As per the code recommended, 1/10 of the compressive strength give the tensile strength of the concrete. So if we know the compressive strength, we easily find out the tensile strength of the concrete. The next one, Young's modulus of the concrete. We all know the Young's modulus of the steel is 2 × 10⁵ Newton per mm square or megapascal. The same, we measure the Young's modulus of the concrete, and we know the compressive strength of the concrete means we easily find out the Young's modulus, that is 5000 root of FCK. So that gives the Young's modulus of the concrete. Thank you.